So after Wilson's theorem, we explored few properties of remainder. Now what are those properties? A raised to n plus b raised to n is always divisible by a plus b when n is odd. That is first property. A raised to n minus b raised to n is always divisible by a plus b when n is even. And a raised to n minus b raised to n is divisible by a minus b irrespective of n. So n could be even or n could be odd. After looking at this, it looks a little confusing. Now let's put this in number to understand it better. So I'll give some number to a, b and n and see what is it like I can get from as a conclusion from this. So let's say a is 17 and b is 10 and n is odd, so I'll keep n as 21. So the problem will be 17 raised to 21 a raised to n plus b, which is 10 raised to 21 divided by a plus b. What is my a? 17. And what is my b? 10. 17 plus 10. What will it be? 27. A raised to n plus b raised to n is divisible by a plus b when n is odd. Odd is n is 21. If it is divisible by a plus b, then what is the remainder? The remainder has to be 0. Okay, and that's what you get from the first property. Let's move on to the second property, a raised to n minus b raised to n. So a is 17, b is 10. Let's keep n as 22 because n is even here. A raised to n, which is 17 raised to 22 minus b raised to n, which is 10 raised to 22, will always be divisible by a plus b, which is 17 plus 10, 27. When n is even, yes, n is even, which is 22. If it is divisible by a plus b, then the remainder for this has to be again 0. And that is what the property states. Let's move on to the next property, a raised to n, which is a, 17, b is 10. So 17 raised to n. Now n is irrespective, which means n could be odd or it could be even. Okay, so we'll see both the case. When n is odd and n is even, is always divisible by a minus b. So this time we have a minus b instead of a plus b. So let's keep first n as odd. So 17 raised to 21 minus 10 raised to 21 is divisible by a minus b. 17 minus 10, which is 7. Okay, if it is divisible, then the remainder has to be what? 0 in this case. Let's take the second part of this property when n is even. When n is even, so what will you say? 17 raised to 22 minus 10 raised to 22 will always be divisible by a minus b, 7. So remainder in this case will always be 0. Okay, in this case n doesn't matter. It could be odd or it could be even. That is the beauty of third property of remainder. Now let's see a problem on this to understand how to apply this property. So I'm being given a problem as 2222 raised to 9999 plus 5555 raised to 9999. Let a be equal to 2222 and b be equal to 5555. So this is of the form a raised to n plus b raised to n divided by a plus b, because n is odd. So this is my first property. Okay, n is odd, 9999. This is always divisible by what then? This is always divisible by a plus b. Okay, what is my a? 2222. What is my b? 5555. So this will always be divisible by 7777, which is a plus b. Okay, so this numerator will always be divisible by 7777, which means it will always be divisible by 7. Some number is divisible by 7777, obviously it is divisible by 7. So what is the answer to this? Then the remainder for this has to be what? 0. Okay, and that's how you apply the property of remainders.